Ever wonder how some apps just feel so smooth? You're like tapping and swiping, and it's like instantly there.
Oh, absolutely.
No lag, no hesitation. That's the magic of, well, a really well-tuned UI, right?
Yeah.
And when it comes to building those UIs on Android, Jetpack Compose is like the tool, right?
Yeah.
So today we're going deep dive into this thing called the lifecycle of composables. Basically, how does Compose manage all those updates behind the scenes to make our apps feel so snappy?
Right.
And we're diving into this with excerpts from, get this, the Lifecycle of Composables document.
Okay, perfect. And that's such an important thing to think about, right?
Right.
Because a janky UI, one that's slow or unresponsive, that can really make or break an app, right?
Mhm.
Nobody wants to use something that feels clunky.
Totally. It's like that instant turn off, right? Like, ugh, this is laggy, and you're gone.
Exactly.
So our document, it jumps right into these terms, composition and recomposition.
Yeah.
And like, I got to be honest, sometimes those words, they just kind of...
Yeah, they can sound a little intimidating.
Exactly. Can you break those down for us, like in plain language?
Absolutely. So think of composition as the initial setup of your UI, right? Compose takes all the code you've written, all those buttons and text fields, and it renders them, it makes them appear on the screen. Now, recomposition, that's where things get interesting. That happens when something in your app changes. Could be the user typing something in, new data coming in from the network, anything like that.
So instead of redrawing the entire screen from scratch every single time something changes, Compose is smart enough to figure out exactly what needs to be updated and just updates those parts.
Exactly. That's the key to keeping things fast and fluid. And that's what we mean when we say Compose is event-driven. It's not constantly redrawing everything. It sits there patiently, waits for a specific event, a user interaction, data change, whatever, and then it's like, okay, something changed, time for a recomposition.
Okay, so it's event-driven, updates only when it needs to. I'm starting to get the efficiency angle here.
Right.
But maybe this is a dumb question, but how does Compose actually know what needs updating?
It's not magic, although it might seem like it sometimes. What Compose does is it keeps track of something called the call site for each composable.
Call set. See, now there's another one of those terms. It's like,
Yeah.
does it require a computer science degree to understand?
Not at all. It's actually simpler than it sounds. Think of it this way. Every time you call a friend, that's like a unique call site in your day, right? You remember who you called, what you talked about. Compose does something similar with composables.
Okay, so it's like each time Compose uses a composable, it remembers that specific instance. It's like, okay, I use this button here with this text and this specific function attached.
Exactly. That's how Compose knows what's truly unique, even if two composables might look identical on the screen. Prevents a lot of unnecessary work, keeps things running smoothly.
Okay, that's actually pretty clever when you think about it. It's
Yeah.
like each composable gets its own little ID card,
Yeah.
and Compose uses that to keep everything organized and prevent those unnecessary redraws.
Exactly. And this whole idea of uniqueness, it becomes even more critical when we're talking about lists of items, which, brings us to our next key topic, this thing called keys. But before we jump into that, anything you want to clarify about these call sites?
No, I think you explained that really well, actually. It's
Yeah.
like it's all about helping Compose work smarter, not harder. Right?
Exactly.
All right, keys. This sounds important. Like, we're about to unlock some serious Compose knowledge here.
Yeah, you're not wrong. Think about it. How often do you see lists in apps? Contacts, messages, to-do lists? It's everywhere.
Right. Pretty much every app has some kind of list when you think about it.
Exactly. Now, each item in that list, that's a composable, right?
Okay, yeah, I get that. Like, my contact list isn't just one big blob of information. Each contact is its own thing, or its own composable in the Compose world.
Exactly. Now, imagine you rearrange that list, maybe sort it alphabetically or something. Without keys, Compose might think every single item has changed position, and it might try to redraw the whole entire list from scratch.
Ouch, yeah, that would not be good for performance. Talk about a laggy UI.
Exactly. Users would definitely notice that. And that's where keys come to the rescue. See, by assigning a unique key to each composable in that list, we give Compose this way to actually keep track of those items, even if their order changes.
So it's like each item in my contact list gets this little name tag that Compose can always recognize no matter where that contact ends up in the list.
Yeah. That's a great way to put it. The document actually gives a really good example with this movie screen composable they use. Say you've got a list of movies, right? And the user can reorder them, like drag and drop.
Okay, yeah.
With keys, Compose can see that, okay, the order might have changed, but the movies themselves, they haven't changed.
So instead of freaking out and redrawing everything, Compose is smart enough to just like shuffle those existing movie composables around because it knows which one is which, thanks to those keys.
Exactly. And this is huge, especially when you start thinking about side effects. Things like image loading, for example.
Oh, right, because you don't want to be re-downloading all those movie posters every time the list changes, right?
Exactly. Without keys, every reorder could potentially trigger this whole cascade of unnecessary image downloads.
That would be a terrible user experience. Imagine, like, you just want to sort your movies alphabetically, and suddenly you're stuck waiting for all those posters to reload.
Exactly. But with keys, Compose can be smart about it. Okay, this movie's image is already loaded. Perfect. Let's just reuse that. Less work for your app, smoother experience for the user.
Okay, keys. Officially amazing. It's like, you know how those little dividers in a toolbox keep everything organized, right? Like, even when you're rummaging around for a specific wrench, everything's still in its place.
Yeah, I like that analogy. And speaking of things that help Compose stay organized and efficient, let's talk about this concept of stable types.
Stable types.
Oh.
Now, this I'm curious about. Does Compose have a preference for certain data types? Are some, like, more laid back and easier to work with?
Not quite. When we say stable in this context, we mean the value of that type isn't going to change unexpectedly. It's predictable, reliable, kind of like that friend you can always count on, right?
And I'm guessing an unstable type is like that friend who's always changing their mind at the last minute.
Right.
Hard to keep up with.
Exactly. Now, why should you, as a developer, care if a type is stable or not? Remember how we talked about Compose being smart about its updates, only updating when it needs to?
Yeah.
Stable types play a big role in that. Because when Compose knows a value is stable, it can relax a little. It doesn't have to constantly check for changes. It can trust that the value will stay the same unless you explicitly tell it otherwise.
So it's like those stable types, they get to skip the security line at the Compose airport. They've already been pre-screened, so to speak.
You got it. Less work for Compose, smoother, faster experience for your users.
Everybody wins. Now, some types, they're like inherently stable, right? Like
Yeah.
your basic ones. Inabud, Boolean, string. Those are always going to be what they are.
Exactly. Those are like your rock-solid friends, always dependable.
Makes sense. But what about when we're working with more, complex types, things that have more moving parts?
You're right. Things can get a little trickier with complex types. But don't worry, Compose gives us a way to kind of vouch for our code, to say, hey, trust me, this type is well behaved. That's where this stable annotation comes in.
A stable annotation.
Yeah.
So we're like giving our code a little gold star, telling Compose, this one's good, you can trust it.
Yeah. Basically, it's a way for us developers to make a promise to Compose. Even if a type looks complex on the surface, like maybe it's an object with a bunch of properties, we're saying, hey, trust me, this thing's going to behave itself.
So no sudden, unexpected changes that would force Compose to scramble and redraw everything?
Exactly. It gives Compose that confidence to skip unnecessary checks and updates because it knows the value won't change randomly.
Okay, so we've got call sites, keys, stable types. I'm seeing a pattern here.
What's that?
It's like everything we've talked about. It's all about making Compose's job easier, right?
Right.
So it can focus on its superpower, those super fast UI updates.
You got it. When Compose can trust our code, it can do all sorts of clever optimizations behind the scenes.
And everyone wins. Our apps run smoother, users are happy.
Exactly. It's a win-win all around.
Now, before we wrap things up here, there was one more thing in the document that caught my eye. Something called strong skipping. What is that? Some kind of superpower?
Strong skipping. Now, that's a whole other deep dive right there. It's a bit more advanced, but basically, it gives a Compose even more freedom to skip unnecessary work, making things even faster.
Wow. Okay, so it's like next level optimization.
You could say that. It's really cool stuff, actually. But maybe we say that for another episode.
Yeah, I think we've covered a lot of ground already today.
We have. But hey, that's what deep dives are all about, right?
That's right. So for everyone listening, we started off trying to understand how some apps just feel so smooth and responsive. And it turns out a lot of it comes down to this thing called the lifecycle of composables in Jetpack Compose. We talked about how Compose is event-driven, meaning It only updates when something actually changes, not just on a whim.
Right, and we dug into how call sites help Compose keep track of every single composable, like giving each one a unique ID tag.
And then there are keys, which are essential for working with lists, because they let Compose know that even if the order of items changes, the items themselves might not have. So no need to redraw everything from scratch.
And let's not forget about stable types, those reliable, predictable elements that give Compose the confidence to skip unnecessary checks and updates, making everything that much faster.
And with that, we've reached the end of our deep dive into the fascinating world of Jetpack Compose and how it keeps our Android UIs snappy and responsive.
It's always a pleasure to geek out about this stuff. Until next time.
And to everyone listening, thanks for joining us on this deep dive into Jetpack Compose. We'll catch you next time for another adventure in the world of code.